Good morning.
Morning.
Morning. People is coming in late today, huh? But I think we just start slowly, so that now, while we are waiting for our classmate, first thing I would like to discuss is about our schedule this semester, right? Originally I have 2 weeks for probability, but considering that we are pulling forward the final presentation like a week, right? So we don't really have too much time left for our final, right? So I kind of today originally the topic of for this unit is introduction to probability, okay? But I think the probability that we are using in this course is actually quite intuitive, right? We are simply using the intuitive idea about probability. Actually, human is born with the concept of probability, right? If you do not have the concept of probability, then you die already, right? When you come across the street, when you cannot survive, right? So people is actually born with the concept of probability. So and in business analytic, for basic business analytic, basically I can say that this intuitive probability that we're born with is actually quite enough, right? What is probability? It's actually the ratio of outcome in repeated random trials, right? See, if a thing is occurring again and again, when it happened many times, right? So it had different outcomes, right? And when it happened, when it happened a large number of times, for example, like 1 million times, 10 million times, then there will be a ratio of this outcome, right? And the probability is simply the ratio that certain outcome would occur when you have many trials, right? Okay, and in business, actually, we are. I think let's take a look at this slide first. Jump to this slide first, right? So this is the business logic. It's only a metaphor, right? Every business has its own unique logic, right? And every business are different. But one of a thing that in this business logic, in every business logic, is actually uncertainty, right? Isn't it? Right? When you make business, there are some uncertainty when a customer, whether a customer will come in to buy next week, how much will he buy, right? You need to make decision as a manager. The difficulty of business decision is actually you need to make decision under certain uncertainty, right? You don't know the future. You don't know what would happen in the future, but you need to do the business plan. You need to do the business decision now, right? That is how business decision is difficult, right? So usually when we are talking about strategic planning, right? Usually we will have some alternative actions, right? And when that alternative options have to apply that alternative strategic action to the business logic, you will have some expected outcome, right? Okay, right. So given action and given this logic, you will expect some outcome, but that outcome would have some uncertainty with it in it, right? Okay, so it's always the case, right? When you are doing business, you are facing a lot of uncertainty internally and externally to your company, right? So how can we deal with this uncertainty, right? How can we make the strategic planning now in the existing of uncertainty? Now, the reason, and actually one of the major reasons that we want to learn business analytics is we can use data to make model, and we can use model to predict the probability. Okay? For example, when I take action 1, and with this business logic, and with the model that predict the probability, we actually can expect the outcome. Okay? So that's how we use data analytic to kind of deal with, to cope with the uncertainty when we are making business strategic planning, right? That is the reason why we want to make model. It's because we want to predict the uncertainty, right? We want to predict the probability. Okay, so well, we can say that the model and the prediction will not eliminate the uncertainty. The uncertainty is still there, right? But with the model, we can actually estimate probability. And with that estimated probability, we can estimate the expected outcome, right? What we mean by expected outcome, it's that it says that when I take action 1, it is not necessary that I will have outcome 1, okay? But I can expect that. I can have an expectation to what outcome 1 is like, right? You will have, for example, if I'm expecting my revenue, right? There will be a average, expected value of the outcome of the revenue, right? I will have expected value of the profit, right? So uncertainty is still there. That expected value is not necessarily realized in the future, right? But there are certain ways to give us an idea about the uncertainty, right? I mean, the uncertainty is still there, but with the probability, with this statistic method, it gives us a way, right, to give us an idea about how to expect this the outcome of an uncertainty event, right? That is the spirit we need to learn in doing business analytics. Is there any problem up to this point of time? Okay, so to give a wrap up, see, our business is to make decision with business analytics, right? And the way we do that is we use data to build model so that we can estimate the uncertainty in terms of probability, right? Okay, and with this probability, we actually can form the expectation of the outcome, right? Okay, so we have expected outcome for action 1, we have an expected outcome for action 2, and we have an expected outcome for our output 3. Okay. This expected outcome is not necessarily realized in the future, but it gives us a reasonable, the most likely expected value, so we can come out. And based on that expected value, we can try to make our strategic choice, right? To make our decision based on the expected outcome. And that is the spirit of business analytics, right? Okay. In the first half of our course, we actually do not put in the idea of probability and modeling yet, right? We simply like explore the data, process the data, right, and try to like look into the history and try to figure out the current situation of our company, right? And with that, we do a strategic planning, right? Okay? But the strategic goal would not realize itself if you do not take some action, right? So when you are taking action, we need to make choice, right? Okay? And when you come to this point, you will need to have the idea about probability, so we can deal with the uncertainty, so we can cope with the uncertainty in our business logic, and we can for every strategic alternative, we can have an idea about what is the expected outcome is like. Okay, that is the basic point. Okay, but when we talk about statistics and probability, it is actually a course of itself, right? Probability take a semester, and the introduction to statistics take another semester, right? We don't really have the luxury to like go through every detail. But as I told you that in this basic business analytic, we don't really need to learn that complicated concept in statistic and probability. We don't really need to think about that binomial distribution, normal distribution, that type of jargons in probability and statistics, right? In this course, I try to make it intuitive, right? In the beginning of the course, I already say that human is born with the concept of probability, right? If you do not have the concept of probability, you actually cannot survive, right? The reason that we have a brain is what is the brain is for, right? It's because you can conceive the environment so that you can predict a future. So when the car is running into you, you can actually like based on what you observe, you can kind of like predict future, right? Isn't it? Intuitively, you already have that probability concept, right? And that intuitive concept is usually good enough for basic business analytics. Okay? So, as I told you, because our schedule is actually kind of like squeezed into only 16 weeks, And the 16 week is not a complete week. You can say that you only have 3 days from the last time of our lecture to our final presentation, right? So I basically will skip the introduction of basically today I will skip the introduction of probability, and don't worry about that. As I told you, that today I will give you an example to show how we use probability in business, and basically it is this logic. Okay, basically it is this logic, right? In our business we have uncertainty, right? So when we are doing strategic planning, we actually need to cope with this uncertainty before we can understand the expected outcome for our strategic alternatives. Okay, how do we cope with this uncertainty? Basically, we use data to make model and use model to predict the probability of every expected outcome, right? And in this way, we cope with the uncertainty. So with this model, we can have an expected idea about the outcome that corresponding to each of these strategic alternatives. And that is basically what I'm going to do today, okay? Because I talk it like repeat this for several times because people are coming pretty late today, right? Okay, so don't worry about that too much about that. Okay, so let's take a look at you will find that we actually have 2 unit A, right? We already have a unit 8 for clustering, and probability in business is actually another unit 8. That is because the previous, if I need to change the unit name, then I'll need to change a lot, right? So I pretty much just reserve the old unit number, right? So I don't have to change too much in my material. Okay, so we have 2 unit 8. And you go to the unit, if you go to the unit web page, you will see that today's information, for today we have like the previous weeks, we will have one PowerPoint file, and we have a zip file, right? Okay, and this is zip file, after you unzip it, you actually will see in your code, under your code folder, you should see a 0A introduction probability. Okay. So for those who that did not download the things, please download it now. Okay. Download the zip file to your code folder, and then unzip the file. Then under your code folder, there will be a folder called 08 introduction probability, and go into that folder. Is everybody here now? Anyone need more time? I wait for you because today we will use app kind of like an app to learn the concept. To learn this concept, actually I will have a data case to guide you to go through this process, this business analytic basic process, okay, with an app. So in order to do that, in order to do that with me, you actually need to have this information, this data and program file. Everybody is here, right? Okay, so we set it to our working directory. Okay, and the first thing we want to do is we want to go to en fed2a rmd. Okay, open this en fed2a.rmd, and if there are some actually I would kind of like suggest you to run this block first. Okay, so if you have some package install, you will have some installation process going on here, right? Is anyone still doing the I will wait some time for the installation to complete. Okay, is there anyone still doing installation package? Anyone? Raise your hand. So you already have every package ready, right? Okay, then next thing you want to do is press this run application button. Okay, after you press it, it will actually open a window and run an application. Okay, this is not the same as the static web page. It is actually an application like this. Okay, usually I would like open it in browser, so it will be easier. Okay, just there's open in browser here, right? So you basically open that in browser. It would be easier for you to use this application. Okay, the application is made up of several pages. Okay, as you can see that we will have a lot of pages in this application. Okay, so today I'm basically using this data case, the old phase data case, to bring everybody to go through this scenario with everyone, right? We start with a story which comes with a data, right? And then we'll teach you what is a model, how we build model, and how we use model to predict probability, and then how we can use this probability to make business decision. Okay? And so as I say, you don't really need to learn too much about probability. Just the intuitive concept of probability is good enough for today. Okay? Now let's take a look at the story first. Now the story is talking about this. You know Yellowstone, right?
Oh my God! Video.
So
Oh my God!
okay, so Yellowstone is in Yellowstone there are some like fountains, right? And this is not actually fountain. This they call it I don't know how to pronounce it, geyser, right? So this is a kind of like a fountain that it would like start to like erupt, and then for a few seconds, a few minutes, and then it will stop, right? So and then after a while it will erupt again, right? So in the beginning people are like just waiting there. went to see the fountain. In the beginning, nothing is happening, right? So and people are gathering there, try to observe the fountains, right? And after a while, it starts to erupt, right? And sometimes you will, and then you stop, right? So the story is basically like this, okay? And with this story, we have the data, right? We have the time of eruption, and we have the time of waiting, okay? So here we have like 272 eruption event. So the first event, it erupted for 3.6 minutes, and then wait for 79 minutes, okay? And then it erupt again, and this time it's 1.8 minutes, and then it wait for like 54 minutes, okay? So we have a data here, right? And this is the history, right? Okay? We say this is a sample, right? Because that this fountain is called Old Festival, right? It's called Old Festival because it's like erupt like, for example, maybe 10 million times already, right, in the history, right? And it's still doing this intermittent eruptions. And we only have 272 eruption events, right? So we basically take the history events, and with this event, if we do some basic statistic, we basically will have some idea about the average eruption time, right? And the average waiting time, isn't it? Right? If we do like basic statistic, we will know that the eruption time, the average of eruption time, is actually 3.488, right? It's about 3.488, and the average waiting time is about 70.9 minutes, isn't it? Right? So with that, can we have the expectation that the next eruption, right? With this statistic number, we actually can form some idea about the average eruption time and average waiting time, right? However, when we actually plot this eruption time and waiting time into a chart, now with this number, with this average number, you would expect that most of the eruption will have the eruption time for about 3.5 minutes, right? It's about here, isn't it? Right? And most of the eruption will have a waiting time for about 70 minutes, right? But it's not the case, right? As you can see here, right? You can see this is the I simply like make a point plot, right? And you can see that the eruption and waiting time, this eruption event actually are clustered in two groups, right? And one group have a short waiting time and short eruption time, and the other group have a long waiting time and long eruption time, right? And if we try to expect the time of next eruption using this average eruption time and eruption waiting time, we are not likely to hit the real thing, right? Okay? So it's not reliable, okay? When we make the chart, we will realize the fact that simply using the average to predict the future is not reliable, right? isn't it? If I simply relies on this average, I would expect that something will happen in 3.5 and 70. Most of the event would happen here, right? But it's not the case. Okay? So we need to use the data to build model and use the model to like predict probability. It would give us the more reliable way to predict, right? Which means, in another word, it say that if we actually use this data to build a model, and with the model we can have a better prediction about the outcome. Okay? So there are many ways to build model and many different kind of models. Okay? And today I'm going to like show you a few ways to build model and show you a few ways to use this model to do prediction. That's the objective today. Okay? Now, let's turn to the next page. Are you following me? Can you see this page? All right, in your own computer. Okay, huh? So, in the beginning, I would let's do some setting first. Let's try to. There's a kind of like a sliding bar here, right? Put the sliding to 0 first, right? So you won't mess up the thing, okay? And then I would like, let's just leave this data route, and okay, for all of this checkbox, let's only have the data route chosen, right? Then you will see something like this. Okay? Now, suppose that we are going to like make a model about the prediction time. Okay? I mean, we want to, prediction time is kind of like in probability, we say that the eruption time is actually an uncertain value, right? Okay, and we know that, this thing is like very troublesome. When it appears, I cannot do anything. Okay. How can it should disappear, right? Yeah. Okay. Now do it very carefully. If we look into the data, right? If we simply look into the data, we'll see that the average eruption time is about 3.4 minutes, right? It's about 4.4 minutes. But when we are going to like build a model to help us do the prediction about the eruption time, right? Okay. And the first thing that we can do is actually we can like, this is the eruption time, right? The x-axis is the eruption time, right? And eruption time is a random variable. We call it random variable because it is kind of like, it's variable, means that its value would vary, right? Okay. And in the history, we can see that in the range of its of this random variable, the minimum is like 1.6 minutes, and the maximum is like 5.1 minutes, right? So we know its range, right? We know the range of this random variable, okay? And we also know for every occurrence of this value, we actually can put a mark here, right? This data route. This is the range of the random variable, and this is the history Okay, every rock is actually, every mark is actually an occurrence of this random variable, right? So in total we have 272 occurrence. So we simply like mark 272 mark here, right? In its range, okay? So, and we say that we are going to find the distribution of this random variable, okay? A model, the model that we are going, that we use to predict the value of the random variable. Let me say it again. The model that we use to predict the value of a random variable is basically usually we will use a distribution, okay? Distribution as a model to do the prediction, right? And one of a model is kind of everyone is very familiar, is already very familiar, it's called histogram, right? If we put this checkbox, we will see a histogram here, okay? Right? So histogram kind of give us an idea about the distribution of this random variable of eruption time, okay? See, and if you go through this data mark, you can say that in some value range, it is more dense, it's denser, right? And in some place, they are sparse, right? Okay. If we look into this, if we look into the statistic, we might know that the average is around 3.5, right? But actually, it is not the case, right? You can see that the distribution is like this, right? You know the way that we make this histogram is like we kind of if the occurrence of this random value happen in this range, like more often, then we'll have a higher bin, right? We call this bin. In histogram, we call this bin, right? We divide the range of the variable into equal width, into bins of equal width, right? And then we count the number of the occurrence within this bin, and then we can draw a histogram, right? This is the way we make histogram. We use it like quite often, right? But this is basically how it works, and it gives us an idea about that. If we want to expect the eruption time in the future, it looks like in the time in this range, the chance of occurrence is actually higher than in this range, right? So this is basically histogram, right? Okay. But histogram has actually when we do histogram, we can choose the number of bins, okay? Sorry. If we change the sliding bar here, right? If you can actually have like as large as many as 40 bins. It means that the more bins, the narrower the bin width, isn't it? Right? Okay, and you can actually choose only 10 bins. Then the bin width is actually wider, right? Okay, so if our purpose is use this model to predict the future, So the question is, there's one question for you, right? So how many bin is optimal, right? You have this problem, isn't it, right? Well, as you can see that if I use this only 10 bins, we can actually make a prediction, but it's not very precise because right, the prediction is kind of even out and not very precise. It cannot reflect the data very well, right? However, if I do this, right, if I do like 40 bins, okay, the model is more complicated, right? And the model is actually close to the fit to the data better than a small bin number, right? It is closer, right? It is like more detailed, right? But with this detail, we can see another problem. You will see this what we call glitch, right? You will see a very high bar here, and then a very low, and then it's high, it jump up again, and it jump down, right? Here you can actually see some of these glitch things, right? Okay. And in real situation, in the real life, actually, this kind of glitch is it actually happen. It can simply happen here because in this sample, because we only have a very small number of sample, right? Okay. So if the model is fitting to the sample too much, it would lose its generality, right? It's not general enough. It will very specifically match to the sample, right? So a very detailed model is not always a good idea, right? If we matched the sample too much, actually it will lose the generality. Okay, so in our course we don't really have the time to discuss how to find out the optimal number of bins. Okay, the levels of details. Okay, usually we will say that if the sample is too simple, then it is not detailed enough, right? Okay, we will say it under-fitting, right? Because it did not fit the data very well, did not fit the sample very well. And if the model is very detailed, we would say that it is over-fitting. It means that it fit to the sample. It matched the sample too much, right? So it's lost the generality. So you cannot use this. It means that it fit because it's too close to the sample, though that it cannot has. When we extend to the future, it is not necessarily better, right? So there's a big issue to choose the right number of bins, right? It is future. Usually we would like to choose the number of bin starting from the low number of bin and then increase the number of bin until the breach happened, right? So in this case, I would say that the number of bins of 18 is actually quite well, right? Because it do not have the bridge. Okay. But usually when we draw the histogram by R, it will have a D4. It means that it already in the R histogram function code, it already have some basic internal algorithm to choose the level of detail for you, right? So basically you just use the D4 setting, right? To choose the number of bins is actually not easy, especially when you are doing a complicated model like machine learning and artificial intelligence. Okay, overfitting is actually a big problem, and we need to do a lot to cope with this overfitting problem. Okay, but in our course we don't really have time to discuss that, so it simply relies on the default labels of detail that come with the function call itself. For histogram, we just rely on the default number. You don't need to specify anything, right? Just use the default histogram function call, and it would choose a label of detail for you. Okay, that's basically what we will do in our course. Actually, we don't have time to discuss about the underfitting, overfitting problem, right? But the important thing is that we learn here is that with the same data, when we are using a method, histogram is a method, right? So you use the data to build the model, okay? Except choosing the model method and give it the data, you need to specify the labels of detail. But in the basic business analytics, we kind of relies on the default label of detail is usually good enough, right? Okay, so that is what we want to cover here. The important thing is that with this data, with this method, we can have a model that gives us an idea about the distribution of this random variable. And with this model, we will have a basic idea about how to expect the occurrence, the value of this random variable in the future. Okay? So, this is already 10:04, so let's take a 10 minutes break. We'll be back at 10:15, okay? So everyone can kind of run the app in your own computer, right? If you cannot, please go to me or go to the TA.